if we wanted to find the speed of a wave and we knew the distance it travelled in a certain amount of time, we could just use speed equals distance divided by time. Or if we wanted to know the distance it travelled and we knew the speed and the time, we use distance is speed times time. Okay, the wave equation is kind of a form of that, but it takes into account the specialist parts of a wave, so like wavelength and frequency. Okay, so we start off with an analogy. The number of waves that pass a point per second is the definition of what of a wave? Number of waves per second. Frequency, yes. Remember, frequency is the number of waves n divided by the time taken. If a wave travels faster, then the number of waves passing per second is obviously going to be higher, yeah. Because if you run faster and you're doing laps of the track, if you run faster, then I'm going to see more of you than if you were just walking around the track. Yeah, so if the wave travels faster, the number of waves passing per second is higher. The speed of the wave is related to the frequency of the wave. So the higher the frequency, the more times I see you per second, the faster you must be going. Okay, so look at this analogy. So suppose a goods train is emerging from a tunnel at a speed of 10 meters per second and the trucks are 5 meters long. Okay, so there we've got a tunnel, each truck is 5 meters long and it's traveling at 10 meters per second. Okay, so if it's traveling at 10 meters per second, what length of train comes out of the tunnel every second? Clues in the name of the speed? Yeah. 10 meters every second. So 10 meters of the truck comes out in 1 second. So if each truck is 5 meters and 10 meters come out every second, how many trucks come out every second? 2. 5 times 2 is 10. Yeah. I see where you're thinking comes from. Yeah. So we've got 2 5-meter trucks make up 10 meters. So remember, frequency is the number of waves every second. So in this case, the frequency is the number of trucks every second. So what is the frequency of trucks? 2. Yeah. We just said 2 trucks come out of the tunnel every second. Okay. Truck length is just the length of 1 truck. 5 meters. You're determined to get 2.5 in there somewhere. Okay. And the speed of the train is not 2.5. The speed of the train is given to you in the question. It is 10. Yeah. So if the speed is 10, the truck length is 5, and the frequency is 2, then we can make an equation from those numbers, because 10 is 5 times 2. So the speed, which is 10, is the truck length, which in this case is 5, times by the frequency. So in this case it was 10, 5, 2. Somebody want to put that on silent? Okay, so that's an analogy, but if we replace the truck length by wavelength, and we can rewrite the equation by saying the speed of a wave is the wavelength times by the frequency. And that's quite a lot to write down if you're doing a calculation. So the shorthand way of writing that, using the symbols, is V for speed, F for frequency, and lambda for wavelength. So that's like a sort of an upside down Y. And if you're a fan of triangles, that's the triangle for it. So speed in meters per second, frequency in hertz, and wavelength in meters. Okay, I guess it's because we've got a lot of things that are named W. So we just use a symbol, this Greek symbol lambda for that. Okay. So we're going to go through the mathematical derivation of the equation as well on the next page. So if you're a fan of maths, you probably will quite enjoy it because derivations are always quite satisfying if you're a mathematician. If you're not a fan of maths, don't worry about it. If you're not following it, that's absolutely fine. You don't need to know the derivation. It's just quite interesting to see where it comes from. Okay. I'll just leave that for a little bit. But please feel free to read forward on the next page. You okay? You okay at the back? Jamie, you okay? You sorted? Sorry? All right. It's a Greek alphabet, yeah. I think it's also on some. I don't know if you've ever played. It's quite an old game. It's Half-Life 2. It may be. I don't know. It's in the Greek alphabet, so it could well be. So you're not confused about what it means. You just want to find out what you said it for. Okay. Right. So derivation. So if you're watching waves in a pond pass a point, you can time how long it takes a whole wavelength to pass a point by timing from one crest to the next. You can also measure the distance from one crest to the next using a ruler or to find the wavelength. So using these measurements, you can work out the speed of the wave because speed is distance divided by time. Okay. So if we're using one wavelength, the distance, so the distance for one wave to pass, and the time for one wave to pass, are we okay at the back? Q is the time for one wave to pass is the time period, remember capital T. So speed is therefore the wavelength, which is the distance, divided by the period, capital T. We also know from one of the earlier pages that the time period is 1 over frequency. So we can just replace that time by 1 over x. So that's what we've done here. We've got speed is wavelength divided by 1 over x. And if you rearrange that, then you end up with, so if you basically to rearrange that, your s then has to go up to the top. So you end up with speed equals frequency times wavelength, which is that equation again. So it's just basically another form of writing. It comes from speed is distance divided by time. Okay. Right, so some examples of the wave equation. So it's relatively straightforward to use, but you need to watch your units. Okay, and I know a few people fell foul of changing units in the nuclear test, so it's a lesson to be learned from that, which you'll find out tomorrow as well. So, crests of a water wave pass a point every 0.5 seconds. So that means one wave passes in 0.5 seconds. What's the time for one wave to pass? It's the time period. So that is that time period. The distance between consecutive crests is 3 meters. So distance between one crest and the next is also called the wavelength. Yeah. So the first question is nice and easy. State the wavelength of the waves. It's just that 3 meters. Okay. B. How many water waves pass a fixed point in 1 second? Well, we say crest of a water wave pass a point every 0.5 seconds. So one wave passes in 0.5 seconds. So if one is in 0.5 seconds, how many would be in 1 second? Yeah, 2. So 2 waves in 1 second. So the answer to that is 2. C, state the frequency of the waves. Okay, well, remember we can work out the frequency using the number of waves divided by the time taken. So we've got number of waves is 1 in 0.5 seconds. So 2 hertz. That makes sense because remember frequency of waves is the amount of waves passed in 1 second, which we worked out in part B. So we've got the wavelength. But the wavelength is 3 meters. The frequency we've worked out to be 2 hertz. And it's asking us for the speed of the water waves. So we're going to use our new equation. Speed is frequency times wavelength. So 2 times 3, which is 6 meters per second. Okay. Have a go at question 2. You're using the same equation, V equals F lambda. So have a go, but you're going to have to rearrange it to find the wavelength. Remember, lambda is the wavelength. So you just want to put the numbers in and then rearrange it. Remember, exam technique, best way to do that is put numbers into the equation, then do your rearranging. I mean, you could use speed as distance divided by time, but then you'd have to work out what the time is first of all, yeah. So it just take you an extra step. So you should get your answer to that 2.27 meters. So the important thing there is just to pick out, yep, and read the question properly. Did everyone get that?
And see when the calculator comes up as a recurring number,
Yep.
and see if it's distance, would you put it as recurring?
Always rounds it. Never use recurring in your final answer. Toby, you okay? You're looking a bit, yeah. The final question. In an experiment to measure the speed of sound, a pupil places 2 microphones 0.8 meters apart, so very like the experiment I did last time, and finds the time taken for the sound to travel from one microphone to the other is 2.3 milliseconds. Calculate the value he obtains for the speed of sound. So what we've been given, so we've got a distance apart, and we know the time it takes to get there. So we've got a distance traveled, and we've got the time it takes to get there. So 2.3 milliseconds. So remember, change it into seconds. We want to find the speed. So we haven't been given the wavelength, and we haven't been given the frequency. But we do have all the values that we need for a different equation, which is what? Speed equals? Yes, thank you. So you just need to be careful when it asks for you to find the speed. It could ask you to find the speed, and you might need to use the above equation v equals f lambda, or you might need to use this equation. So don't despair if you're like, I don't know how to answer this because I haven't been given the correct information. It's probably you just need to use a different equation. Okay. So the distance is 0.8 and the time is 2.3 milliseconds. And that should come to 348 meters per second. So a few things to look out for. Make sure you're using the correct equation. So write down everything that you're given in the question and then decide which equation to use. And also watch your units. Other than that, they should be nice and easy. Okay. You might need to use a few equations in one question, so you might need to find the frequency first, then find your speeds. So there's quite a few equations, quite a few questions to practice on these from the booklet. I'm also going to set you a homework to do a Firefly quiz again to do for next week as well on these V equals F lambda questions. Okay. So question booklet, page 6 to 9. Just practice. Then, as I said, practice, practice, practice. The more questions you do, the easier it will be. Yeah.